You ever wonder about the invisible lines that connect, well, everything? I'm talking about the way you're connected to your friends, the way roads connect cities, even how the entire internet holds together. It turns out there's a hidden blueprint underneath it all, and today, we're going to pull back the curtain and take a look.
So, here's a bit of a riddle for you. What do your circle of friends, a city map, and the internet all have in common? I mean, they seem like totally different things, right? You've got people, places, and technology, but believe it or not, they're all built on the exact same fundamental idea. And solving that puzzle is what this is all about. Okay, so let's start with something we all know, a social network. You can picture each person as a dot, and the lines connecting them are their friendships or maybe their professional ties. It's this huge, sprawling web of relationships.
Now let's swap that out for a city map. The intersections? Those are our dots. And the roads connecting them? Yep, those are the lines. It's the same basic concept, dots and lines, just representing something totally different.
And for our last piece of the puzzle, here's a computer network. Every single computer, every server is a dot, and the cables or the Wi-Fi signals connecting them are the lines. See the pattern here? People, places, technology, it doesn't matter. They all share this blueprint of points and connections.
So the answer to our big riddle is a simple but incredibly powerful idea called a graph. Now, I'm not talking about the XY axis chart you might remember from math class. No, this is a totally different beast. It's a way of thinking about, well, about how anything is connected to anything else. So, what is a graph, really? Let's break it down. Turns out, it's made of just two super simple building blocks. These two things are the foundation for every network we've looked at so far. So, here are the two pieces. First, you've got your vertices, which some people also call nodes. These are just the individual things, the dots in our pictures, the people, the cities, the computers. And second, you've got edges. The edges are the lines that connect the vertices, the friendships, the roads, the network cables. Seriously, that's it. It's all just dots and lines. And this is just a perfect illustration of what I'm talking about. On the left, you've got a diagram of a real computer network. It's kind of busy, a little complicated. But on the right, we've turned it into a graph. All those computers and servers are now just simple dots, vertices, and the connections are clean, simple lines, edges. This is why graphs are so powerful. They let us strip away all the noise and just focus on the structure of the connections. Okay, so now that we know the basic building blocks, let's learn how to speak the language of graphs. There are just a few key terms we need to know to really understand what this blueprint is telling us. First up is a word called adjacency. It sounds fancy, but it's super simple. If two vertices, two dots, are connected by one single edge with nothing in between, we say they're adjacent. Think of them as next-door neighbors. They have a direct link. Next, we've got the idea of a path. A path is exactly what it sounds like. It's a route you can take through the graph, hopping from one vertex to another by following the edges. It's like a set of turn-by-turn directions to get from point A to point B. And here's the path in action. Let's say we need to send some information from PC1 all the way over to PC2. One possible path would be to go from PC1, connect to server 1, then from server 1 to server 2, and finally, server 2 makes the connection to PC2. See? We're just following the lines to get where we need to go. Now, this is a really important concept. On the left, you see what we call a connected graph. This means you can start at any dot and find a path to any other dot. It's one big, cohesive network. But on the right, you see a disconnected graph. It's broken up into little islands. There's just no way to get from one of those groups to the other. And knowing this difference is absolutely crucial for everything, from making sure a computer network is reliable to understanding social cliques. All right, that's enough theory. Let's get to the really cool part, seeing how this hidden blueprint is secretly running all sorts of technology you use every single day. You ever use a GPS or an app like Google Maps? Well, you're using a graph. Every intersection is a vertex, and every road is an edge. But here's the magic trick. The app adds a weight to each edge, which is basically the time it takes to drive down that road. Your phone is then just running a crazy fast algorithm to find the shortest path, not the shortest in distance, but the shortest in time. You know when you're shopping online and it says, hey, people who bought this also bought? That's a graph too. Every product is a vertex, and an edge gets drawn between two products if people buy them together a lot. So when you add oven mitts to your cart, The system just looks at the vertices that are adjacent to it, like the muffin pan and the cake mix, and suggests them to you. It's all just pattern matching on a giant graph. And of course, the most obvious one, social networks. On a site like LinkedIn, you are a vertex. Your connections, they're the edges. And the whole system is constantly analyzing this massive graph to find paths between people. That's how it can tell you, oh, you know Shayla and she knows Manuel who knows Riva, suddenly revealing a connection you never even knew you had. It's pretty clear that this simple idea, just dots and lines, is unbelievably flexible. The source material really nailed it with this quote. Graphs give us a flexible way to model almost any scenario involving connections, physical, digital, or social. And that's really the heart of it. This one core concept works for the roads we drive on, the technology we use, and the people we know. So from now on, whenever you get a product recommendation or book a flight or just find your way across town, you'll know what's going on under the hood. You'll see that hidden blueprint. And that leaves me with one final question for you. Now that you know what to look for, what other hidden networks do you think are shaping your world?